Right.
So we're saying they will substitute the values. How are you going to solve the left hand to get F? Then you divide both sides by 1.
Sir?
How are you going to get the value of F? You want to make F subject of the formula. So you come and divide here by what? By 6, 63 times 10 to the power negative
34. Negative 34.
That when you divide here cancels out. So that is your value for the F. When you punch in your calculator, what are you going to get when you simplify this? Punch it. But tell me what is your answer. What are you getting as frequency?
Yes, sir. Can I please quickly do it?
Solving this number.
Say got 7,50 multiplied by 10 to the power of 19.
7,50. You rounded off yourself or what?
Yes, sir.
Yeah, correct. But there must be units. What are the units? You did not say the units. Must be in hertz frequency. Must be in hertz frequency. Okay. When they say what is F, must indicate 7,50 times 10 to the power negative 19 hertz. That is frequency. So always you are going to, when they talk of electromagnetic waves, you are going to use this formula. E is equals to H. Always Planck constant is given. And then you just check what is the energy. Or you can be given frequency, and you have Planck constant, then they say calculate the energy of the particle. You see? So,
Yes.
so in this question now, they are saying which wave AB has higher penetrating ability? Give a reason. Give a reason for your answer. Which wave, A or B, has higher penetrating ability? So by penetrating ability, we mean the energy of the what?
It's the wave.
The wave. So which one? A or B is the higher penetrating ability. Give the reason for your answer. So which one is the highest frequency between A and B? Go to A, go to B. Which one is the higher frequency?
It's B.
B, because it has higher frequency, and also the particle of the energy is greater than the what? The one for A. So it's higher frequency and higher energy of particle. Those are the reasons that you are going to give. Those are the reasons that you will give. There's the largest frequency and largest what? Energy. Can you see it?
Yes, sir.
It's supposed to be A, not F. A. Yes, the largest what? frequency, and energy. Simple things. There's nothing difficult about what we are writing. You practice, you sit down again, analyze the question, nothing is difficult. There is, and revise those scope which were given by you. And let's go to the last question now. Since you said electricity is out, isn't it?
Yes, sir.
So let's go to the last question, which is number 6. Then you rest, and then tomorrow morning you warm up. You warm up using the same question paper and those notes. You'll be ready to write. You'll be ready. They just repeat these things. They change values. They just
Yes,
change
sir.
values. So 2 identical metals, B and C, placed on insulated stands carry charges. So this one is a positively charged. Positively charged, meaning positive because of the plus. This one is negative as shown. So respectively, when they say respectively in the same order, which means this is B, it's a plus, which means this is B. And also this is what? C. That's what? Coulombs. So charge is measured in what? Coulombs. This is the unit for charge, coulomb. Coulombs, coulomb. Okay. So if they give you like this to say nanocoulombs means what? The number that you are given times 10 to the power negative 9. You must know nano, then to be negative 9 coulomb. This n, small n, means nano. If they say micro coulombs, the trick there, micro is like this. If they want to trick you, they will just say micro coulomb, so that you know it's 10 times 10. Micro is 10 to the power negative 6.
Yes, sir.
Must know those things. Micro, nano, milli, coulombs, etc. But if they trick you, yeah. But if they just want you to pass, they'll give things which are clear. So it's just for example. Nano times 10 to the power negative 9. Micro times 10 to the power negative 6. The number that you are given times 10 to the power negative 9. So in our question, the spheres are allowed to touch. When they touch, they attract each other, isn't it?
Yes, sir.
Once they've attracted, positive and negative attracts, then they attract. After they are attracted, they repel, because all of them, they are what? Having the same charge. Get it?
Yes,
That's
sir.
why they move apart from each other. So the question is saying, state the principle of conservation of energy. So that principle of conservation of energy, it says that the net charge of an isolated system remains constant. So in an isolated system, the net charge remains constant. That is the principle. Yes, the principle of conservation of energy. This one. The net charge of an isolated system remains constant during physical process. So the net charge, what do they mean by the net charge? Which means
the overall charge.
Yes, that is the one that remains what? Constant.
Constant.
What do they mean by isolated system? By isolated, what do they mean? Isolated means no energy. In this system, there is no energy loss. Isolated means there is no
energy loss.
Yes, energy is just converted from one object to the other, but there is no energy. Which energy? In the form of charge. There is no charge that has been lost. So either the charge is lost by another sphere, and then it will be gained by the other sphere. So this is an isolated system. It's a closed system, in other words. It's closed. It's not an open system. A closed system. That's what isolated means. No energy loss there in an isolated system. There is no energy. There is no charge loss, charge that is lost. All the charge is gained by the other sphere. That's what we must know this. Okay.
Yes, sir. Yes, sir.
Then the question is now saying the number of electrons transferred between the two spheres during contact, 6 months. So this is the process of you coming to the number of electrons that has been transferred. So first process that you do, first add the two charges. What do you get? This charge is 4. When you add them, when they are in contact, what are the charges? Add the two charges. What do you get?
So say on the calculator, I write them as is with the 10 to the power of -6.
Yes. Put it on the calculator like that. Even on paper, you do it like that. You
Yes,
write.
sir.
Yes. So we are going to say on paper, you write it like that on paper. For example, plus 4 times 10 to the power -6. You write it on paper, -6 coulombs. But here you are just dealing with numbers. So you remove the coulombs in the calculation. Then you say plus. This is the net charge which you are talking about. What are we adding? We are adding a negative number plus -6 times 10 to the power
-6.
bracket. So when these two spheres are in contact, their charges, they share charges when they are in contact. That's why we are dividing by what?
-6. So by 2.
There are 2. So the charge for this sphere B and the charge for sphere what? C. You add them. Isn't it they've attracted to each other? So when they are in contact, you are adding. Contact, you are adding. But there is a positive and a negative. So the mathematics, it will say what? What is the final answer on your calculator when you add these numbers and you divide by 2? What are you going to do? Put it in your calculator.
Yes, sir.
Put it in your calculator so that you see what you are going to be doing tomorrow. So that if there is a problem, you ask now. Otherwise, when you make mistakes, so that is the first thing. You add the two charges, then you divide by 2. What are you doing?
Yes, I can't see the. Is it +4 or is?
Yes, positive. But +4, you just know it's 4. On a calculator, there's no need of you putting positive. You just say 4. But on writing on paper, you'll be saying +1. 4 on paper, isn't it? But on calculator, you just know any positive number, you just say 4. You don't have to say positive. So it's 4 times 10 to the power 6. Then here, you know positive times negative. It's negative, but you can use the calculator. It will just solve for you once.
Say I got -0,0000003.
You got negative
0,0000003.
when you put it in a calculator. Is that what you got?
Yes, sir.
All right. So what do you conclude? -0,0006. Was that the final answer?
It was 0,003, sir.
All right. Let's see. We are just saying 4 plus -6. What is 4 minus 6? Mathematical. In other words, you are just saying 10 to the power -6 bracket 4 minus 6 over. That's what you are just saying. That's what it is. What we are just representing this. Then what is 4 minus 6? So it's negative 2.
2.
In other words, negative 2 equals to 10 to the power negative 6 bracket 4 minus 6 negative 2 divided by, there's a 2 down there, so divided by negative 2. So actually the answer, it will be equals to negative 2 divided by 2 is negative 1. In that bracket, that bracket is indicating times 10 to the power negative 6. So where are you getting
6?
3? Where are you getting 3? What was your answer?
It's from the calculator, sir.
It's you who is punching the calculator. Don't tell me it's from the calculator. Huh? It's you who is punching the calculator. You are telling the calculator what to do. So the calculator will always give you an answer. I'm saying from the calculator, what answer did you get? Because this is the answer which is correct. The answer which you must get is negative 1 times 10 to the power negative 6 coulombs after they are in contact with each other. And what did you get on your calculator after you saw? That's what I'm asking, so that I can correct you.
Oh, sir, I made a mistake and type on 16 instead of 6.
Or did you correct and are you getting the same answer?
Yes, sir.
And are you getting the same answer?
Yes, sir.
You've corrected and they are getting the same answer. Is that so?
Yes, sir. Yes, sir.
So after touching, now each sphere is now having this charge. So before, sphere B was having 4 times 10 to the power negative 6 coulombs. So in other words, if they don't want to give you times 10 to the negative 6 coulombs, they will just say the charge was 4 micro. They will just do like this, micro coulombs. Then they say the other one was negative 6 micro coulomb. So you're saying you must convert this micro. You must know it's times 10 to the power. Times 10 to the power. Hello. Are you
Hello.
there? I'm saying it's times 10 to the power what?
Negative 6.
Yes. Otherwise, they will give you this, then when you write something else, then all the marks are gone. You must know this micro means 10 to the power negative 6. If they put NC like this, a micro minus 6, they mean instead of saying minus 6 times 10 to the power negative 6, you are going to say minus 6 times 10 to the power negative 9. So you must be able to interpret this, what it means. If they've given you numbers like this, then they will give you, it will be a giveaway. But if they want to be tough, they will give you this symbol. Then you interpret, you bring back to number. N means times 10 to the power 9. Micro means times 10 to the power 6. We must know that. Right,
Yes,
let's go back to our question now. Let's go back to our question, which we answered, so that you see how do you maneuver to get the correct answer. All right. So we said the spheres are in contact. Each sphere now is having this. We have calculated it. How do you calculate it? Add the two spheres and don't forget to divide by 2. So now the question is saying calculate the number of electrons transferred. First, you must know how many electrons did each sphere gain, the gain of electrons. So how do you calculate the gain of electrons? We are going to say this since it moved from a positive charge, this was a positive charge. Now the charge is now minus 1 times 10 to the power negative 6 coulombs. So what is the gain? How do you calculate the gain? The gain of electrons, the charge. How do you calculate the gain? How many coulombs were gained by this one? Did it gain or did it lose? The positive one.
It lost.
It lost. That's why it's negative, isn't it? And then the
Yes, sir.
Charge C gained, because from negative 6 to negative 1. Now big, isn't it? It gained, isn't it?
Yes, sir.
Yeah. So in other words, you can either use each of the charges. You can say you want to calculate the gain of the charge before you calculate the number of electrons. How many coulombs did each charge gain? So that gain, you say the final amount is this one, the final charge. So we are going to say which one gained here?
The positive.
Yes, yes. So here they were saying calculate the number of electrons transferred during contact. So this one is the one that gained, the one for charge C. But you can still use any of the charges. You come back with the same answer. So the final was negative 1. This is the final times. What is negative 1 times 10 to the power negative 6 coulombs? That is the final, minus the initial. So it's minus the initial. The initial was minus. Can you see?
Yes, sir.
So don't forget the minus. If you are dealing with this one. Minus 6 times 10 to the power negative 6. What are you getting? What do you get? Put in your calculator. Only number. And you tell me what you are getting.
Yes, sir. I got 0,000005.
How many zeros?
After the comma, there are 1, 2, 3,
But
4,
after
5.
the comma, all the zeros. I said all the zeros. You don't say after the comma. You say how many, all the zeros.
It's 6 zeros.
Yes,
6 zeros.
When you're calculating, you don't say after the comma. You say I have 6 zeros in total. And your number is equals to what? Which number are you seeing? The number which you are seeing there on the calculator after the zeros? Hello.
5.
It's a?
5.
Okay, you say 5. That 5 times. We are seeing how many zeros?
6.
Yes, then you say minus 6. Those are the zeros which you are seeing. Yes, that's how you write it. If you see 10 zeros, all of them that are on the calculator, you say 10 times. How many zeros were there? You first put the number that is after the 0. If the number was 001, then if it was 16, 0016, you write 16 times 10 to the power negative because it's a decimal. How many zeros? All of them, even with the one before the comma. If there were 7, All, when you say 7. But in your case, there are how many? 6. All of them. Then that's why it's 10 to the power 6. Can you see it?
Yes, sir.
That's how you convert into the standard form. This is the standard form which I was referring to you last year in grade 9. When I tell you convert the decimal to standard,
Yes.
and now we are using it in physical science. So it's important you know the standard. So that's what we mean. The gain by the charge on each electron, which means after we have calculated, we subtracted, we have arrived at an answer of that gain on each charge or charge numbers was 5 times 10 to the power negative 6 coulombs. That's why it's 0, 0, 0, 6 zeros. So the 6 zeros are represented by negative 6. You don't say 5 because there are 5 zeros. No, all of them. We are counting all of them.
Yes, sir.
That's how you write it. Like. Then this is the gain. Now you want to know how many electrons were transferred. The question, this gained a charge of that. So how many electrons were transferred? That's what you want to know. Calculate the number of electrons which were transferred. So the number of electrons which were transferred, the number of electrons which were transferred, you have a formula. So the number of electrons which were transferred during the process. You say it's equals to the charge Q over the charge of an electron, which means it's QE, charge of an electron. And where do you get this formula from? This formula, you find it there at the back of the question paper, given that formula, this one. Let me show you. N. N is representing 1. Can you see this formula?
Yes, sir.
Yes, that's where you are getting. That formula for charge, that charge for each sphere, we calculated the charge which was the positive 4, and we calculated the charge which was the negative 1. 6, isn't it? And then what did we do? We added. But because positive and this one just give you negative, so it was just the same by saying 4 minus 6 times 10 to the power, which means you are adding those charges. After you add, you divide by what?
By 2.
Then you check this charge is the charge on each sphere. The charge on each sphere. That is the charge on each sphere. But this formula does not give you the gain. They don't tell you the formula for the gain. That is their trick. So the gain, now you say that charge Q1, or here we use this charge Q2, minus this one after they were in contact, which was Q. Then that's how we find our gain. That gain was equals to 5 times 10 to the power negative 6 coulombs. So from our formula, this gain which we are referring to is what we are referring to here as our Q. That Q. That is what they are referring to as the Q. That gain of charge over the charge on each electron. So the charge on each electron is also given. What you are looking for here is this N. We are going to look for this N. That is our question. Our question is calculate this N, number of electrons. So it's given on the formula sheet. You must know which one to use. Also, these other formulas, they are given as well. They will be given. E is equals to HF. And we said this one is the speed of light. What is the speed of light? Which is 3 times 10 to the power 8 meters per second. That is the speed of light. And it will be given here.
Yes, sir.
This is the speed of light. But only the speed of sound is not there. So the charge on each electron, this is the charge on one electron. It's also given on the formula sheet. charge on one electron. -1, because electrons, they are negatively charged. They are electrons, they are negatively charged. But protons are what? Positively charged. That's why,
Charged.
yes, it's a neutral when they are together. Then that is the charge on one electron. So now, the matter of now substitute. We come here on our formula. We come and say, we have found that the charge on each sphere is this one. How much was the gain? The gain on Q, this is what they did. The final charge, this is the final charge. What was the initial charge of C? This was the initial. So the final minus the initial. That's why they are subtracting. So this is the final minus initial to find the change. That is what they did there. The final minus the initial.
Initial. Oh.
Also they did the same here. They got, this was the final charge after they touched each other. This one is the final charge after they were in contact, minus the initial before they were in contact. This was the initial before they were in contact. So that they find how much did this one gain. So what they are looking for, the change. This change in Q, it means the gain. What change? Either a gain or a loss. So this one, it lost what? Electron. That's why there's a negative. And then this one, what did it do? It gained what? Electrons. There's a plus there. All numbers, the positive. That's why this one did not lose, but it what?
Gained.
There's a plus. So when you are dealing with the negative now, the one that gained, that lost electron, that is the one which you use the sign of the gains. That's why the sign there is now negative, so that they cancel with the negative. If the sign here was a positive, like they did not include the sign here as negative. But on the formula sheet, you can see that the sign is what? The sign here on the formula sheet is what? It's negative. Can you see? Can you see it there on the formula?
Sir.
Yes. But here they did not put the negative here. The reason why they did not put it is because the gain there was a positive. So always never put a negative on the top and on the bottom and then a positive. Always there must be positive, or there must be negative, so that you can cancel out. Because at the end of the day, you want to get a number of electrons. There is no number of electrons which is negative. You are no longer looking for charge. You are looking for number of electrons. And where did coulombs go? Here there was coulombs, and here there was coulombs. So the coulombs, they cancel out. Units, this unit, they cancel out. Then you are left with only a number. Here it was -5 times 10 to the power 6 coulombs. The charge for this one, for each electron, is this. So the units, they cancel out. The numerator and the denominator, they cancel. You have done exponents. If there's an x on the numerator, there's an x on the denominator, what do?
Cancel out.
Yeah. That's why the number of electrons that were transferred, which is represented by this formula, is that. So the formula that is not there on the formula sheet is the one for gain. So for them, they tricked you. They said they gave you this formula for calculating the charge when the electrons are in contact. And they gave you this formula for calculating the number of electrons. But they did not give you the formula for calculating the what? The change in charge, which is change in Q, which is the gain or the loss. That one which we're saying final minus initial. Any question?
Yes, sir.
You have a question? want to ask?
No, sir.
Yes. So that marks the end of our discussion. That marks the end of it. This is not coming. Because you said you did not do electricity.
Yes, sir.
So it is not done. But electrostatics, it will come. Electrostatics, it will. Just master these things that we have done. You will pass. You will pass.
Yes, sir.
Planck's constant. You revise your things. You know how to use this formula. It says E is equals to HF. E is equals to HF. It's given there on the formula sheets there. But just know it by head for you to be fast. But given on the formula. Given on the formula. Just know it, but it's given on the formula. Given. Let me open it for you so that you see it. This one. E is equals to HF. Or E equals to Planck's constant multiplied by the speed of light. Maybe they tell you what is the wavelength lambda. Then you look for lambda, make lambda subject to the. What is the unit for constant instead? Oh, I think I've done justice on my side.
Yes, sir.
Fantastic. If I get time, I'll share the video. Maybe you'd want to repeat here and there.
Yes, sir. Thank you, sir.
Okay, I will end it here now.
Yes, sir.